Dharma. I would be having a web session on Docker for beginners. So this session includes basic understanding of Docker and some hands-on experience on basic Docker commands. So I will split this session in multiple videos, so it's easy for you to follow and go ahead. So to start with, what is Docker? So this is uh, for beginners who don't have idea about what is Docker. So if in case you know about Docker, this would not be interesting for you. So the first thing what we would be doing here is the question is why we are discussing Docker. What is the need of the Docker? And then we will have some hands-on Docker. So it's pretty basic, playing around with Docker. Before that, we will have some understanding of basic terminologies in Docker and how do we install Docker. So I would install Docker on Linux, but I will tell how it's done on Mac and Windows. Then we talk about Docker networking a bit of, not in detail. Then I would talk about Docker TLS. So TLS comes after installation, which means that how securely the Docker client and daemon talk to each other in the application as an application. Then we'll play around with Docker commands a little bit. We will have some commands to run images, check images, and some processes and lists. After that, I will have a Docker file session, talk about best practices of Docker file, and we'll also talk about what are the various things we do in Dockerfile. Then we'll run a simple application, simple Java application, which is a hello world, and build it via Dockerfile and run it in a container. So that's about the agenda. So before we start Docker, the first question is why are we discussing Docker? So if we go with this time machine thing, or we go back, we have evolved a lot as a software development. So we started as a traditional deployments, wherein if you see, you have a typical hardware operating system and application. So it's organizations ran these applications on physical servers, and multiple applications were running on the same physical server, which so happened that the resources were mostly taken up by another application, and then there was a need that we should have another physical server, but again you tended to underutilize because you don't use the rest of the processes or CPU and memory. So this was good, but it is now expensive for the organizations that you have to completely maintain this. And this is almost a traditional, and I don't think so most of the organizations are doing it until otherwise it's needed. So then came the virtualized deployments, wherein you were allowed to run multiple virtual machines on a single physical server, and this was good in a way because your applications will be isolated between VMs, and it provides a level of security which cannot be accessed by another application. Another good part is there's a better utilization of resources in terms of physical server, and it reduces the hardware cost because you don't have to buy more physical servers. But the one part here is that each virtual machine is a full machine, like its own operating system. It's like a full blown system, and it needs some effort for you to build this everything. So I don't say it's a bad approach, but yes, it's good. It reduces your system, but it does a lot of heavy lifting with respect to your setting up virtual machines. Then comes our container deployment, which is kind of similar to virtual machines, but they are way lighter. So if you see, there is no hypervisor here. So you directly have a hardware with the operating system and then a container runtime, and that's the reason they are considered lightweight. So similar to VM, they have their own file system, CPU, memory, but they share the same kernel space. Needless to say that they are decoupled from the underlying infrastructure because they are portable, but that's all because of this container runtime, which enables and makes it more like a infrastructure agnostic. Now there comes a lot of advantages with this container deployment. uh, so since we are writing more of containers which are more lightweight, we are evolving from traditional monolithic applications to microservices. And with the advantages of microservices, that you are doing a rapid development across a service which whose life cycle is bound to that particular service and not to the whole application. And then this brings us to a rapid continuous development and integration process wherein you build image, push image, test it. That's pretty fast. And dev and ops are separated totally, or we can say they can be interchangeable here, because once you are in the process of creating application with images, and you are with the process of dev and ops. Another best part is you run the same on the laptop as it does on the cloud. Of course, the application is same. There are changes, but the whole purpose is that you have the predictability of the application the way it is running. Yeah, so that's pretty much about the evolving from traditional to container. So I don't say that traditional is bad or container is good. It's about the how we are evolving and how organizations are adapting themselves to have a fast delivery of their applications. Now our focus is on Docker, so let's be more specific on container side. And the other part I wanted to tell here is that this session is more about understanding it as a developer, not as a more internal into the Docker, but it's aspect that which is nice to know that what's happening underneath the Docker. So we have a rough idea what we are playing with. So Docker is, as I said, it's a container deployment way, which is application, a client server application, which can be run on a host, and it has its own ecosystem. So Docker is run as a daemon on a host, and since it's a daemon which is listening to your request, there's a client which is talking to it, and it has something called images, which are like a cut short version of operating system, you can say, or a web server which is being pushed into registries. So registry is something where predefined images are pushed. It's something like the packaging managers, if you consider for any operating system or any packaging utility. And these are managed in various ways. We would not go into it. Like one example is Docker Hub, and images are managed by Docker daemon, and also containers are spawned by Docker daemon. What are these things? We will talk later. I will explain what is a container, what's the image. And from the client, when it talks to Docker daemon, it's need not be necessarily from the same system, but it can be across the network. And the challenge of how we are interacting it by making it secured, which is also I'll talk about it later. Yeah, so this is a 30,000 feet uh, architecture of Docker. It's more abstract, but we get a feel of what actually Docker is. Now, with the terminologies of Docker, we need to know a lot of few things here, which makes us to do installation also very easy. So we have a Docker D, which is basically a Docker daemon, which is a daemon running on the host, which listens to the request from the client. And again, Docker, yeah, it's the client which talks to the server or the daemon for processing your requests. We have something called a Docker engine. So it's often a confusing term which you read across documents. So this is basically a client server application. So it's like a suite of Docker D and Docker. So when you say a Docker engine, it's a request from Docker going to the Docker daemon, and Docker daemon interacts internally with the REST APIs to talk to its own application, and that's what is Docker engine. There's something called a Docker machine. So it's more of installing a Docker engine on virtual hosts. So it can be Oracle VirtualBox, which is majorly used. But Docker machine I would not be talking about in this session, because it needs more of, or this would be more used during your testing phases where you want to run or your applications and do some testing. If you're using a Linux machine, you don't need a Docker machine at all, because Docker does not run as a virtual host on Linux. So that's one. The Docker machine, you can spawn a Docker engine, evaluate your Docker CLI, and start interacting with it. That's more of Docker terminologies, and they have few more. So you have Docker images. So as simple as a template for creating Docker container. So we define a set of rules how the container should run, and that's the image basically. Like a, if you consider it or map it to object oriented world like a Java, image can be a Java class, and container is an instance running. So it's a runnable instance of an image. There is something called a service, which is in a broader term, which says that we can scale containers across multiple Docker daemons, and this comes in picture when we are running in a distributed system. So one example of with Docker is Docker Swarm, where multiple Docker daemons are running, and they are connected to each other, and the services are being maintained by the swarm. So this is more associated with the swarm or Docker Swarm. To achieve it in a single Docker, we can run it via Docker Compose. So that is something which is little advanced. I'll come later, or I would be covering it maybe in the next sections. Yeah, so that's pretty much about this section wherein we introduce Docker. Next section, I would talk about um, installation of Docker on Linux. Thank you.